A blessed day, everyone. Welcome once again to our new lesson. Today, our topic is about series and parallel resistor combination. So let us check first the series circuit, and let us define what is series circuit. Components connected in series are connected along a single conductive path. So the same current flows through all of the components, but voltage is dropped or lost across each of the resistance. In a series circuit, the sum of the voltages consumed by each individual resistance is equal to the source voltage. So for the formula, solving for the total resistance, we have here total resistance is equal to R1 plus R2 plus R3, because we have here in our circuit that we have R1, R2, and R3. So what if we have another resistor? We're just going to add that resistor here. Like for example, we have here another resistor and we label it as our R4, and we're just going to add here another resistor as R4, and that will be our formula for the series circuit. So let us continue with the parallel circuit, and let us check the series parallel circuit and define what is parallel circuit. So a parallel circuit has two or more paths for current to flow through. Voltage is the same across each component of the parallel circuit, and the sum of the currents through each path is equal to the total current that flows from the source. So here we have here a parallel connection. And how can we tell that this is a parallel? Because according to this, if the current flows across components has a different direction, like this one, current flowing here, this is current 1, and another current will flow from this circuit, and this will be our current 2. So if this is the case, this is now a parallel circuit. Okay, so let us continue to our formula. So we have our formula for here. Let me just check that one. Formula for two parallel resistors. So if we have like this two parallel resistors, the formula that we're going to use is R equivalent, or the R total, is equal to R1 times R2 over the R1 plus R2 if we have two resistors in parallel. So what if we have another resistor here that is in parallel with the two previous resistors? Okay, so this is more than 2, so we're going to use this formula, more than 2 parallel resistors. So we're going to use the formula 1 over R equivalent, or R total, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we're checking that this is your R1, R2, and R3, if that's the case. Okay, so let us continue. So let us have our example number 1. So here we are tasked to solve for the equivalent resistance or the R equivalent across nodes A and B on the figure below. So let me check my, so here, so node A is this one. So we are tasked to solve for up to node B, which is this one. Okay, so we are required to solve the entire circuit up to this node from A to B. Okay, so let us continue. So here, so first, there. So first, before we proceed, we're just going to combine and look for the parallel resistors connection. And here it is. So this one, R3 and R4 is in parallel. So we're going to combine R3 and R4. So with that, we're going to use our formula for two parallel resistors. And that is R equivalent or R total for R3 times R4 over R3 plus R4. So this is R3 and R4. We're going to combine this. Okay, so let us proceed. And for our solution, we're going to get the values for R1. So R3 instead, or rather, R3 is 30 ohms here, and 15 is our R4 here. R3 and R4, so we're going to place it here. So 30 and 15 over 30, which is R3 here, plus R4, which is 15. So 30 plus 15 here. Now let us proceed. So our R equivalent will now be 450 over 45. Okay, so because 30 times 15 will give you 450, and 30 plus 15 will give you 45. So 450 divided by 45 will give us 10 ohms. Okay, so the total resistance for this parallel connection is 10 ohms. Okay, so let us proceed, and that will be our equivalent circuit. Since we combine this R3 and R4, this will be our new circuit, combined circuit, R3 and R4, with a total of 10 ohms from our computation. So this will be our new circuit, and it is now a series circuit going to node A to node B. Okay, so let us continue. So here, since we have the series circuit now, from here going to the end node of B, we have a series circuit because the current will flow in only one path or one direction. So we only have here one current, So we can tell that this one is a series connection now. So we're going to use the formula for series, and we're just going to combine the R1 plus R2 plus R3 for the total resistance here. So our R1 is 5, R2 is 20 ohms, and our R3 is 10 ohms, the combined parallel for R3 and R4. Okay, so let us check there. And we're going to just replace the values for R1, R2, and R3. Okay, so here I'm just there. So for R1, this is R1 and the value is 5. And for R2 here, and the value is 20. And for R3 is 10 ohms. R3 and R4 is 10 ohms. Okay, so we can now add this and get the value for the R total. The R total, or the R equivalent for the combined series now, is 35 ohms for this series circuit. Okay, so let us proceed, and this is our new circuit. So combining these three resistors here will give us one total resistor or resistance with a total of 35 ohms based from our computation. Okay, this is the simplified circuit getting the total resistance. Okay, so let us proceed for our example number 2. So we have now a new different circuit for this example number 2. So as you can see, we have two parallel connections, which is this one and this one. Okay, so how are we going to solve this? So this is exciting. So let us proceed. And so combining the two parallel resistors, we're going to first solve for here, solve for this parallel resistor first. So the formula for two parallel resistors is R1 times R2 over R1 plus R2. So this is the R1 and R2. We're going to combine this parallel resistors. And proceeding with the next, we're going to solve and get the values for R1 and R2. So getting the values, we have for R1, we have 10 ohms, and we place it here for R1. And for R2, we have 5. Okay, 5. And this is R2. And R1, which is 10, plus R2, which is 5, will give us 50 over 15. So combining 10 times 5 will give us 50. So 10 plus 5 will give us 15. Okay. So what will be our result if we divide 50 divided by 15? So the answer will be for our total resistance. So that is the value here for this combined resistors R1 and R2. The total resistance or R equivalent for R1 and R2 now is 3.33 ohms. Okay, so let us continue. And this will be our new circuit. So here we have now our combined resistance for R1 and R2 as compared to this one. We already combined the R1 and R2. Okay, so let us continue for the next combination of parallel resistor. So here we're now going to combine this three resistors. Now the formula for more than two parallel resistors will be different, and this is the exact formula for combining more than two parallel resistors. It should be 1 over the R equivalent or the R total is equal to 1 over 4, which is this one, 1 over 4, then 1 over 5 for this, 1 over 5, then so 1 over 6 for this. Okay, so we can now combine these three resistors, and let us get let's go to for our solution. So we're going to replace the values for R4, R5, and R6, which is for R4 that is 20 ohms, and place it here, and for R5 that is 20 ohms, and this is the 20 ohms for R5, and for R6 that is 40 ohms, and this is for R5, R6 40 ohms. Okay, then we're going to add this fraction, but we cannot just add this fraction here because we have a different denominators. So we're just going to get the LCD for this fraction. Okay, so let us proceed and how to get for the LCD of the fractions, since so we have here 40, so we're just going to multiply that one, this 1 over 20 by 2 here, 2 and 2 to make it 40, similar to this, and this one 1 will be multiplied by 2 and 20 will be multiplied by 2 to make it similar to this denominator. Okay, so let us continue, and here we have now the similar denominators of 40, which is our LCD. So 1 times 2 is 2, and 20 times 2 is 40, and 1 times 2 is 2, and 20 times 2 is 40, and this will be retained as 1 over 40. Okay, so we have now a similar denominators. We can now add this fractions, similar denominators. Okay, so let us continue, and adding those similar fractions will give us 5 over 40, because 2 plus 2 plus 1 will give us 5, and 5 here. And since we have a similar denominators here, we're just going to place it here as 40. So this is our answer, 5 over 40. So let us continue. And in order for us to eliminate this 1, we're going to raise it by negative 1 to eliminate this 1 over R equivalent. And applying that negative 1 will flip this fraction. So 5 will be here and 40 will go up to its position. Okay, so let us continue. So there. So R equivalent, or the R total for R4, R5, and R6 will now be 40 over 5. Okay, so we can now divide 40 over 5 will give us what? 8. So our R total, or the total resistance, or the total resistance or equivalent resistance here is 8 ohms. Okay, for this 3 resistors, combining 3 resistors will give us 8 ohms. Okay, so let us check the equivalent circuit. So now the new circuit is this one. Combining R4, R5, and R6 will give us 8 ohms, similar to what we had solved. Okay, for the total resistance of this 3 resistors, R4, R5, and R6. Okay, so we can now combine this as a series combination. Okay, so let us continue. So here, this is our series circuit, and we're going to apply now the formula for the series connection. Okay, so we're just going to add R1 parallel to R2 plus R3 and this R total for this parallel R4, R5, and R6. So this is our formula. The total resistance for R equivalent of R1 and R2 plus R3 plus R equivalent of R4, R5, and R6 will give us this one. So replacing the values for R1 and R2 is 3.33. From this one, this is the 3.33 ohms. And for R3, we have 50 ohms. So this is the 50 ohms for R3 plus the R equivalent for R4 and R5 and R6, which is 8 ohms, and this is the 8 ohms. So combining or adding this values will give us the total resistance or R equivalent of 61. So 61.33 total resistance for this circuit. Okay, so let us check. And here is our new combined circuit. So here we have one resistor combined with all these 3 series resistors. So we have now one total resistance of 61.33 ohms. Okay, so that will be our final answer for this total resistance combination of the resistors. So let us now proceed with our example number 3. And here, so we are tasked to solve for the voltage V1 across the 5 ohms resistor shown in the figure below. So we are tasked to solve for the voltage 1 across the 5 ohms resistor. So here in this example number 3, we are now tasked to solve for the voltage, not just the resistance here. So we're now going to solve for the voltage drop of V1. Okay, so let us continue. So first, in order for us to solve for the V1 here, we need to combine first the parallel resistors here, which is R1 and R2. With that, we're going to use the formula for two parallel resistors. So with that, the R total or the R equivalent for the R1, R2 times R3 over the R2 plus R3. So for this R2 and R3. So we're going to combine these two resistors to make it as one total resistance. Okay, so to continue, so we get the values for R2 and R3. So R2 has 20 ohms and this is 1. Okay, and R3 has also 20 ohms. So with this, if we have two similar values for two or more than two resistors, uh, the result will be just half of the uh, resistor 1, this one, or one resistor. Okay, so half of 20. Okay, so it will be just 10. But if we're going to continue to apply our formula, we can do that by applying this uh, R2 times R3 over R2 plus R3, which is 20 plus 20. Okay, so let us continue, and doing that will give us R 20 times 20 will give us 400, and 20 plus 40 will give us 40. So 400 divided by 40 is the total resistance for that R2 and R3 will be 10 ohms. Okay, so similar with the idea of the half of this resistor, one resistor. So again, if you have a similar resistors in parallel, similar values, you just get the half of that. So the half of 20 is 10. Okay, to get your shortcut result. But if you want to do this, it will give us the same result. Okay, so let us continue for the equivalent circuit. Since we combine this R2 and R3, it will be just one circuit having the 10 ohms based from our computation, and that is from the combination of R2 parallel with R3. Okay, so now this is just a one circuit. Okay, a series circuit. So we can now solve for the V1 voltage drop across 5 ohms resistor, and that is V1. So let us now proceed with that, and solving for the voltage V1 will give us the formula of 6 volts. So 6 volts is here the total voltage Vt, and R1, which is 5 ohms. 5 ohms, this will be R1 over 5 ohms, which is also R1. So R1, so this will be our original formula, plus 10. So 10 is from this combination. which is 10. So this is supposedly R, just R2. Okay, so this will be our formula. So solving for the formula, let me just solving for V1, we will be needing the voltage division or the voltage divider principles for that. And that is V1 is equal to voltage total times R1 divided by R1 plus R2. That should be the formula. So by getting the values for those uh, resistors and voltage, let us replace. So replacing them is that 6 volts, and adding this 5 ohms plus 10 ohms will give us 15 ohms, and same with this one, 6 volts, you just retain that, and 5 ohms retain, and we just solve first for this one, which is 5 plus 10 will give us 15 ohms. Okay, so let us proceed. The result for that, let us go back. Okay, here the result will be the result for that is V1 is now 2 volts here. By calculating this, V1 will give us 2 volts. So V1 will be 2 volts here. Okay, so since this is just the voltage drop for V1, so we assume that V2 here will be doubled by 2. So V2 will be 4 volts. So combining 4 and 2 will give us the total of the voltage source of 6 volts. Okay, based from the doubled value of 10 ohms from 5. Okay, so now we able to solve for our V1, which is 2 volts. We proceed with the next solution. So here we are tasked to solve for the current I using Ohm's law. So we able to solve for the voltage V1. Now we are tasked to solve for I, not just I1 but the total current. Okay, the current flowing here, the total current flowing here. So this is I total. So we are tasked to solve for the total current flowing inside this circuit, series circuit. So let us continue. So solve first for the total resistance. Okay, so R total. So we cannot continue if we are not going to combine the two resistors here. So we're just going to get the R total of this two. Okay, and let us proceed with our formula. So with that, we're just going to add R1, so which is this R1 plus R1 parallel with R2, the result of R2 and R3, and get the values. That is 5 ohms plus 10 ohms. 10 ohms will give us our total of 15. Okay, so 15 our total, and we can now apply the Ohm's law, which is V is equal to I times R, the voltage the current times the resistance. Okay, so here V, total voltage, is visible or given because we have the total voltage source here of 6 volts. And for our total here, we have just got the 15 ohms, and the unknown here is our current. So we're just going to transpose that outside, and we will have the formula for that, I. So the formula will be I is equal to V over R. Okay, then replace V and R with its values. Okay, so for V, we get 6 volts and place it here. And for R, we get 15 volts or 15 ohms and place it here. Now 6 volts divided by 15 will give us what? Total current, which is 0.4 ampere. Okay, so this is our answer for this given problem. Okay, so I hope you learned so much for this lesson, and we're done. We're done again. Okay, see you for our next lesson. Thank you so much, and God bless.